Hello and welcome back. Today I want to take a moment and talk about some of the tips and tricks that I usually use when using LTspice. So these don't really refer to a particular feature, it's just a collection of various things that made using the program so much more easier, at least for me. And some of these, if you didn't already know them, might be helpful for you in the future. So if you're curious, then keep watching. So first things first, the color palette. I guess one of the reasons why LTspice isn't bigger and, well, more well known than it already is, has to do with the way the program looks like. So in the default version, you have dark gray, black, and dark blue. Now, what do these colors remind you of? For me, it's a thunderstorm. And when I'm working, I don't want to look at the thunderstorm. It doesn't really put me in my happy place. Now, LTspice is a tool used for engineering work, so it's not supposed to be joyful or pink. It's supposed to be calculated and precise. It's supposed to be German. So the first tip is about how the colors and the general visual aspect can be changed, if this bothers you, of course. So this is what the default color scheme in LTspice looks like. And if this is good enough for you, then well, leave it as it is. But especially for me, when making things like videos, having a lot of traces with this color scheme doesn't make things very clear all the time. So over the years I had to slowly change the color scheme and will make things a bit more clear and more visible. So first things first, under the tools, color preferences, we have the option to change the colors for the various things like wires, junctions, and so on, using this slider interface. So here especially, with the background, I like to go with a nice and clean white background. So this makes the circuit pop out far better. Similarly, for the waveforms, again, we can change to a white background rather than having the black one. And well, yes, I agree with everything. And well, now it's all white. But now the traces aren't all that visible anymore, so they seem quite thin and quite, well, faded. So the next option is under Tools Control Panel. And here we have the Waveforms tab, where we can play with the trace width, so how thick is the trace in the Waveforms panel, so we can make it 3 pixels thick. And of course here we can play around with font size and font type. And well, the boldness of the font. So we can make this a bit bolder, a bit larger. And now we have thicker traces, bolder writing, and well, everything is far more clear now. In a similar fashion, under the drafting options, we have the text properties for the schematic window. And of course, if you don't like what you set, you always have the reset to default values in all of these windows. And well, we have hotkeys. So here you can set for the various interfaces, so either for the schematic, the waveform, symbol, and so on, various different hotkeys, so various combinations of keys with which you can more easily work with the program. So these might be some of the things you could be interested in. Next, one of the problems I get quite often, especially with imported simulation models, is the time step too small error. Now, one issue closely related to this is the simulation takes forever problem, which isn't really an error, but rather an inconvenience. The general problem behind both of these is that some circuit node somewhere starts oscillating at a very high frequency, and the simulator needs to calculate this oscillation, which takes time, of course, and well, small time steps in between simulation points. The higher the frequency, the smaller the time steps, and the more the simulation time will be. Of course, depending on the situation, you might not really want this. So you want to somehow prevent this phenomenon from occurring. And this takes us to the CS Hunt option. So for this next step, I prepared the basic circuit with an op-amp with the MCP 6001, and I got a simulation model from the manufacturer's website. And if we run the simulation, well, we get an error. We have a time step too small error, and well, there's trouble with node U121. So this is some node inside of U1, which is the op amp. Now, you could try to go inside of the model and figure out what the problem is, but that's not really the issue today. So we can fix this by using a specific option. And to figure out what we should do and what the option means, we can look in the help file. So under help, we got the help topics, and mind you, LTspice is a great help system, I really enjoy using it. And here, under options, we see all of the various options that can be set using the .options statement. So today, we're interested in the CS hunt, which is a statement that will add optional capacitance to every circuit node. So this simply means that every node in the circuit will have some small bit of capacitance to ground, which is not really completely unrealistic. So if we add e to the minus 14 farads, which is 0.01 picofarads, circuit now works. No more issues. So we don't have any more problems. The circuit is amplifying as expected, so now the circuit works just fine. So in general, when you have time steps too small problems, you can add this optional capacitance to every circuit node, something in the range of 10 to the minus 13, 10 to the minus 15. So very small amounts of capacitance, and usually this will fix things, unless you have some other issues. Next is one of those tips where I don't even know what the tip actually is, but I know a simple way to find it. It has to do with various options which are displayed when you click on them in just the right way, taking things like component power dissipation, RMS value, current through trace, and component attributes. I honestly have no idea what the exact key and mouse combination is. I just know it involves either the Alt or Control key together with either left or right mouse buttons. It's some combination of these. So let's take these one at a time. If we stick to the circuit window and we go over component, well, we can click it, but if we also press the Alt key, we get this thermometer icon. And if we click on the component now, we get the power dissipation on this component being plotted out. So LTspice will figure out exactly what the formula is to calculate the various voltages and currents related to this component, and it will simply plot out the power dissipation occurring on that component. Next, if we go over a trace, we get this voltage probe symbol, so left clicking on a trace will give you the voltage on it. But again, pressing the Alt key, we get the current probe icon, and this will plot out the current running through that trace. Now, it's important to mention here that although you could get the current simply going over a component, like with this resistor, so I'm not pressing any keys at the moment, when you do it over a trace, the simulator will take into account how the circuit is drawn out. So what's left and right of the trace over which you're looking at the current. So if there's a more complicated circuit, it will look at exactly what current would be passing in that piece of the trace. Finally, if we go over a component and we right click on it, well, we usually get some settings about the component, but if we press the Control key and right click, then we get the component attribute editor window. So this is especially useful when you want to change the prefix or some other parameter which is not easily accessible. Finally, if we now go to the waveform window and we press Ctrl when the mouse is over the waveform, we can move the waveform around if you need this. But if we go over the values that are being plotted out, so left clicking on them will just bring up the cursor, but holding Ctrl and left click will bring us this small panel which shows us the average value and the RMS value of the plotted quantity. So in a specific interval, it will tell us what the average and the RMS value is for this specific parameter. Now, there are probably some other such combinations, but these are the ones that I use most often. Next step has to do with getting the simulation into the place where you want it as soon as possible. So what I mean by this is that you are not always interested in the very first moments of the simulation, so right when it starts. Unless of course you're looking at startup behavior. But usually you just want to see how the circuit behaves, how the signals and the waveforms in it look like when the circuit is in a stable operating mode. So this tip has to do with the various settings that can be used, as well as the initial conditions or .ic statement. For this example, I prepared a basic switching converter. So here we have the power stage of a buck converter, where the transistor is being driven by a pulse source with a 50% duty cycle. So if we run the simulation and we look at the output, well, it starts at 0, all the capacitors are discharged, and then eventually it stabilizes and reaches the final value of about 5 volts. Now, if you're interested in the startup behavior, then you will be interested in this waveform up to the point where the output is stable. But if you're interested only in the final behavior of the circuit, so maybe you want to work on the output capacitor size or something like that, then you don't really care about this startup. And now there's two ways around this. First would be to simply not show it. I mean, you can zoom into the final piece of the waveform, but well, that just takes effort. So the other thing you can do is go into the simulation command and not just set the stop time, so when the simulation stops simulating, but also set the time at which you want the simulator to start saving data. So all data before this will be calculated, but it will be scrapped. So for example, if we set here 1 millisecond, we rerun the simulation, we still see a bit of an oscillation, but the voltage is already around 5 volts. So all of the initial startup was scrapped, and we just see this final almost stable waveform. Now, even though we didn't see the rest of the waveform, it was still calculated, and that took time. So the next best thing we can do is use the initial conditions statement. Since we know exactly how the circuit will behave when it's in a stable point, we can already induce this state from the beginning. So we know that the output voltage will be around 5.08 volts on the Vout node. So we can simply write a statement to set the voltage to 5.08 volts from the beginning. Of course, we need to take out the time to start saving data modification, and if we rerun and we look at the output voltage, it starts from 5.08 and then quickly stabilizes. But we still have a bit of a wiggle here. And this is coming from the fact that we don't just need to set an output voltage to get the converter into a stable state, we also need to stabilize the current running through the inductor. So we don't just have the option to set voltages in circuit nodes, we also have the option to set currents through components. And with this inductor, we know that the current will stabilize around half an ampere. So again, we can write an initial condition statement. So to set minus 0.5 amperes. So it's minus 0.5 because, well, this is the way the simulator is displaying it. And if we rerun the simulation, we can see that we're very close to the final stable version, both with the current and with the voltage. So if you want to get your simulated circuit into a stable state as quickly as possible, you can use one of these two options. Next step has to do with components. Now, especially if you're using some more obscure components, they will probably not be a default model present in LTspice. And if you just never bothered, or you couldn't find a dedicated simulation model for them from a third party, you have no simulation model. So what do you do then? Now, I'm specifically referring here to active components like diodes and transistors. But to a certain extent, op-amps also fit the bill. And the tip here is that rather than leaving the default model, use any component in the library, something that is at least similar to the component that you want. This way you will get far more reliable results. So for this example, I came back to the switching converter and I made a copy of the circuit where the transistor and the diode have no specific model attached to them. So we have the generic NMOS and the generic diode. Now, if we run the circuit, no error appears, the simulation is running without a problem, and that is because these components have some default parameters. We can check them in the help menu. So just to check the diode, we see that there are some default values for all of the parameters, but if we check the circuit's behavior, so we have 10 volts input, 50% duty cycle running into the transistor, we would be expecting the output voltage to be half of the input, and well, that's exactly what we get with the first circuit. But with the second circuit, for whatever reason, it's not really working. So I don't know which of the parameters with the default components are a problem. The point that I'm trying to make is that you should not use the default components. So try to find any component that is as close as possible to what you actually have and just use that. It will most likely give you far better results than using the default unspecified component. Now, this problem is valid for mostly active components, so diodes and the various types of transistors. But there's one special type of component, the op-amp, where you have a set of universal op-amps present in LTspice. So to a certain extent, you can work with these, so you don't really have this big of an issue with these components. But here again, it's far easier to just use some component and that will probably work. So just look for something that's close enough to whatever component you have. This final one, I guess, is sort of obvious, sort of not. It's something that is perfectly reasonable in a circuit simulator, but completely unrealistic in real life. I do it quite a lot in most videos, or whenever I'm working on something for myself, and it refers to having multiple copies of the exact same circuit with small variations. So when I work on a circuit and I'm trying to improve something, but I also need to see if the changes that I've made are actually producing some useful results, I like to compare the new circuit to the old one. So I keep both circuits in the simulator to be able to compare multiple parameters. Now, for this example, let's look at power supplies again, but use a circuit already found in the simulator. So when you look under power products, you have a lot of components made by LTspice and analog devices, and the really nice thing about these is that you also have a macro model example circuit. So I don't have to be bothered with building the circuit, placing in all of the components. We have a default schematic already prepared with this. So this is another good tip to keep in mind. Now, the circuit works, so that's why it's in the simulator. But if you want to work on it, change something, maybe change the transistor, you don't like this IRF7413, you want something else, well, you could change it, so simply right-clicking on it, pick a new MOSFET, but then you wouldn't know if it works better or not compared to the default schematic. So one of the things you can do is to make a copy of the initial circuit, so completely copy it. Make sure that you don't copy net names because this will cause problems, so simply cut out the net names wherever this is applicable. And now I can work on my second circuit, change out the transistors for example, and run the simulation. So now I have both the old schematic and the new one, and I can look at various parameters. So there doesn't seem to be much of a difference between the two, but the point is, when you're tweaking a circuit and you're just trying to find small differences and small incremental improvements, having both the old circuit and the new one at the same time in the simulator makes the job of comparing them much easier. And well, two circuits will turn to many eventually, so as you add more and more modifications, but with today's computing power, that doesn't really matter. So it probably won't take long for the simulator to simulate two or more circuits at the same time, compared to just a single circuit. Now, I guess there are far more tips and tricks out there. These are just some of the ones that came to my mind at the moment. And these are the ones that I personally use the most often. But let me know what tips and tricks you have. So the more you use the program, the more you will end up learning about it, and the better you will be at using it. And I'm pretty sure you also have some really interesting experiences with LTspice that are worth sharing. And with that said, hope you got some useful information after this. Leave your thoughts in the comments. Thank you for watching. Make sure to subscribe to be up to date with all my latest videos, and see you next time. Bye bye.